Hello, how's it growing, friends? Welcome to Office Hours, your source for free cannabis cultivation education. My name is Keisha, and today I am moderating solo. But you know how we do. We're going live on YouTube, so if you're logging in over there, make sure you send us your questions. If you're active on social media, be sure you're following us on all the platforms. We are on Instagram, TikTok, YouTube, LinkedIn, and Social Club. If you're live with us here and have a question, type it anytime in the chat. And if your question gets picked, we'll either have you unmute yourself or I can ask for you. Jason, it's just me and you today. How are you?
Yeah, it's quiet show, quiet house. I'm doing pretty well.
Awesome. Good to see you. All right. Well, let's get to it. We already have some questions that we've received. Dave Ray wrote in, if we have plants that are smaller than we would like in early flower, would it make sense to start steering vegetatively before the typical day 21?
Uh, Possibly. I mean, obviously, the ideal situation here would be to veg for just a little bit longer. And when we're talking about crop registration, for me, that's one of the biggest factors in making sure that I have a predictable, reproducible crop, and that is looking at the plant height when we're coming out of veg. And so, uh, ideally, taking a plant height coming out of veg, we're hitting that day every time that we do veg a specific genetic, and then keeping track of plant heights throughout that generative sharing. Most of the time, if we do go back to some vegetative bulking a little bit early in flower, we're going to see some of that buds structure stretching out a tad bit. Worked with a number of people where they'll see like 2-3 inches of growth in the first couple days of going back to veg bulking, and that's an easy indicator that, hey, we still need to be putting some generative steering to that plant to make sure that we're getting the best bud quality possible.
Awesome. Yeah. Thank you for that, Jason. I'm going to drop in the chat here. We have a really great blog post on the data you should be keeping track of when you're doing crop registration. So that's a good one to reference as you go forward, Dave Ray. Good luck. Keep us posted on what's going on. All right. I'm going to keep it moving to our submitted questions. And if you have a question, be sure to drop it in the chat so we can get Jason's insights. Diane submitted this question last week. We didn't have time to get into it, but he wrote in, Seth was talking about plant metabolism. He says 82 Fahrenheit leaf temperature or 82 Fahrenheit room temperature is the optimum metabolism. What's going to happen if we go above those numbers? Any insights into that?
Yeah, absolutely. And so, when we're talking about some of the ideal metabolisms, leaf temperature is going to be the most important number there. And that's just going to help you target what your room temp should be. For rooms that we have a little bit less far red light, so if we're running under maybe CMH or especially with LEDs, we're going to run the room temps a little bit higher than we would typically with an HPS setup. And so we're shooting for that, probably about 82 range for leaf temperature. Obviously, there can be some slight genetic variation in what is going to help that plant metabolize the fastest. If we go up too much higher, that plant's actually going to start metabolizing a little bit slower as it's using more energy, using more water to try and cool itself. So those stomates are going to start to close up a little bit to try and retain water, and it's going to push water through the plant faster in order to transpire as much as possible, even though those stomates are starting to close up.
Awesome. Thank you so much for that. Diane, thank you for that question. We usually see you on the show. So if you have any other follow-ups, be sure to post those. All right. Caesar submitted this question, and I think we kind of talked about it a few episodes ago, but let's get another overview here. He wrote in, do non-topped plants yield more than topped plants?
Typically, you're going to get a little bit more yield if everything else is the same as far as how long we're growing these. Same nutrients, same de-leafing practices. A lot of times, a top plant is going to give you just a little bit less, right? So this plant is building biomass throughout its entire life cycle, and really, what happens if we are topping is we're just getting rid of some of that biomass. It's going to sometimes slow down some of the growth to that plant. Obviously, topping does have its place. It depends on what's your facility configurations. If we have limited light at the canopy, we want to get as much bud exposed to that as possible. So we might do some training and some topping to try and make sure that that we're getting as much light exposure to the top of those plants as well. Same thing with limited height. If we've got like a 2-tier or a 3-tier flowering room, or we just have a really short flower room, we might need to do a little bit of height restriction in order to just get the best production out of that plant. That being said, a lot of people are successful with pinching to try and do the same type of response in the plant, where instead of having a apical meristem, we're going to have a few branches that are competing for that top light. Historically, with unlimited facility constraints and really good genetics, most of the time, if we're growing a 5-foot tall plant, we're going to see a little bit more bud production, a little bit more total mass than we will if we're damaging that plant and or removing some biomass from it. So my preference usually is to try and have as best of cloning and consistency up to the point, and then you may not need to do topping to even out the canopy quite as much.
Yeah, that's a good tip. Okay, excellent. Well, we got a question in from Iron Armor on YouTube. They wrote in, doing a small pheno hunt and wondering how to keep the seedlings from stretching so much. Roughly how much PPFD can a new seedling take, and what is the minimum veg time before I can switch a seed to flowering? What advice do you have for Iron Armor?
Oh, yeah. So, maximum amount of PPFD for a seedling, it's going to rapidly increase almost on a daily basis as that thing is becoming more mature. When we're germinating, those seeds can germinate in pure darkness. Maybe for the first few days, we'll want to be at like 100 or 200 micromoles. Typically by the time that we are a week or two in, we want to be up in that 300 plus micromoles range, so that we're making sure that we're keeping those plants, like you said, keep them from stretching. A lot of times plants that are not getting enough light for the stage in the life cycle, they'll start to elongate. What they're trying to do is get closer to the light. They're trying to capture as much energy as possible. So, and is really genetic dependent as well. We see some strains that will mature much, much quicker in the early stage. And then we see some strains that don't mature as quick and they catch up, late veg, early flower timeline. So I wish I had exact numbers and times to, put out there, but it just really comes down to what are we working with? And, also comes down to what your light types are. I mentioned a little bit earlier, the increased solar radiation, or excuse me, just radiation from far red. And what that's doing is increasing our leaf temps. And as these plants are smaller, they have even less capability of regulating their leaf temps. Obviously, less total stomates because there's less surface area. And so the little bit tighter controls do help those plants stabilize themselves. So that being said, with something like an LED, you might be able to actually push a little bit more PPFD, especially if it's a LED that doesn't necessarily have a lot of the higher end wavelengths. Obviously, in your fluorescence, that's a great way to start as well, because they're nice and even. It's really nice, consistent, soft light. That being said, we're getting the most light to those plants early on. Fluorescence, you're just going to run out of PPFD fairly quickly and have to transition to a more powerful light type.
All right, awesome. Thank you, Iron Armor, for your question. And, if you have any follow-ups, let us know. We are live with Jason. If you have any questions for the experts, be sure to drop those in the chat on YouTube and here on Hangouts. We got something new here from M5BMW. They wrote in, do you have a template schedule for working with 0.5 GPH in meters for 6x6 rock wool on vegetative and generative feeding? For example, if my lights turn on at 8, my first feeding would be at 10. And for how many minutes then, when would be the next one be for P1 and for P2? Did I say that in a way that makes sense, Jason?
Yeah. So half gallon emitters, what did I say? What is here? 6x6x4 pots. Not really going to matter as much. You'll just adjust how long you are for the size of substrate. My baseline recommendations when we are running generative, 0.5 gallons in a nice, fairly slow emitter. My favorites are a little bit lower than that. Anytime that we're getting into the 1 or 2 gallon per hour drip emitters, we definitely need to increase the number of shots, so that we can try and help the substrate stay saturated, like the capillary effect, trying to avoid runoff, or nutrient channeling, basically. And so, instead of like for 0.5s, I would do, if your lights are coming on at 8 a.m., I would probably irrigate my first shot at 9 a.m. And I'd do 9:15, 9:30, 9:45, till I'm up to saturation. So for um, a fairly aggressive generative irrigation, trying to get up to field capacity within an hour of that first irrigation. And usually we're starting that first irrigation 1 to 2 hours after lights on. And so, in kind of getting back to the point, if you're a higher drip rate, like a 2 gallon per hour, I'd be like, hey, let's try and get, 8 irrigations in to get up to field capacity, just to try and reduce how much water we're putting in there, at a fast rate. So that would be for your generative irrigations, just running P1s. Most of the time, like I said, we'll see between, I like to run at least 4 irrigations, and you could be running up to 8 or 10, maybe a little bit more if you're really fast with your drip emitters. P2s. So when we go into more vegetative steering, I like to actually keep the same P1 that I had. I might need to adjust how much volume I'm getting there at that time, just depending on the plant's needs and how big my drybacks were. But same thing, 8 o'clock, lights on, 9 o'clock, we'll start our P1 irrigations. Around 10 o'clock, we'll be at field capacity, and then we'll start our P2 irrigations to maintain fairly high water content. You may not be all the way up at field capacity. You may be just slightly above it, depending on how much you need to modulate your EC. So anytime that we're above field capacity, we're going to have some amount of runoff. And that typically is going to lower our EC. As long as the substrate EC is staying higher than our feed EC, then some amount of runoff will usually push our EC a little bit lower. Obviously, if your EC is below your substrate EC, or excuse me, if your substrate EC is below your feed EC, a lot of times it just means that we're feeding a little bit too less of nutrients. We want to up our feed EC just slightly. So it's easy to see that, because when you're doing irrigations, if you see your EC and the substrate rising, then hey, that the plant has used up more nutrients from the substrate than we typically feed it on a day-to-day basis. When that's happening, it's obviously going to be really difficult to employ some of the generative crop steering tactics that we talk about, specifically with decreasing the osmotic difference between the plant and the substrate.
That was a breakdown. M5 BMW. Hopefully we answer your question. Let us know if you want to dig a little bit deeper. Thank you for that. Thank you, Jason.
I might come just a little bit more as far as P2s. If we're pushing extremely vegetative, and maybe sometimes if we've got a super small pot size, we're running really big plants, we can run a vegetative irrigation window for 10, 11 hours. Kind of as vegetative as I like to ever go is going to be a 10-hour irrigation window. So that's irrigate first time 1 hour after lights on, and then last irrigation 1 hour before lights on. If you can't do that, then you probably need to up the size of the substrate, just so you can retain some amount of water until the next day's irrigations. However, a little bit more balanced vegetative irrigation schedule might be an 8-hour window. And then typically when we get on the 6-hour window, it'd be like a really balanced irrigation strategy.
So much to think about as far as irrigation goes. Awesome. Okay. Thank you for that, Jason. All right, Cypher dropped a question here in the chat. Cypher, I'm going to read it, and feel free to unmute yourself if you want to add. But he wrote, can you suggest a product that has the accuracy of the Atmos 14? I'm interested in a thermometer, humidistat that will give an accurate reading.
Yeah, so there, kind of a couple different categories of what you're looking for. As far as if it's a handheld, I typically like to go with something that's NIST certified. One of the best things you that are a little bit cheaper that are typically pretty good. Go in and read the specification manuals and see what the accuracy is on those devices. Just try and get an idea of, hey, does that accuracy match what the Atmos 14 is? So when I'm within a, plus or minus 2 degrees error on the Atmos 14, if I'm in plus or minus 2 degrees error on a handheld, well, that means I could be 4 degrees off and still be within the manufacturer specifications. So anytime that we get a lot of questions about, hey, does this need to be calibrated? It doesn't agree with my other sensors, etc. You always have to include those plus or minus accuracy ranges on both devices, because if we're on the high end of the accuracy on one, we're maybe in the top end of those temperatures, and so let's say the room's 80 degrees and one of the sensors reading 82 degrees and the other sensor would be reading 78. Well, both sensors are doing what they're designed to do. So it's nice to get ones that agree as best as possible so we can consistently make those decisions. So, NIST certified, that's definitely one of the first things I look for. Good known brands. That's one of the things I like to do as well. If you're doing a hobbyist thing, there's some stuff on Amazon, some of those Chinese models, they're going to be probably okay for what you're trying to do. But at a commercial level, it's nice to have equipment that you can really trust when you're doing this. So check out those specs manuals. And the way I do things is I always try and read as many reviews as possible and get an idea. Hey, 2,000 people had really good success with this sensor. I can probably trust it if everybody else had a good experience with it. The other category for thermometers or humidistats, I mean, you're looking at like wall-mounted stuff that's controlling an HVAC unit. Ideally, we're always trying to control our HVAC systems from a canopy-mounted sensor, and so typically those types of sensors are going to come from the automation industry, so building automation, management, those type of sensors. And again, tons of that stuff on the market. Look for one that's well regarded. Usually doesn't hurt to spend a little bit more money too. Not that saying that's always going to get you a better sensor, but typically it costs a little bit to manufacture a rugged, high accuracy sensor. And so, in the end, you're going to have to pay for it a little bit in order to get something that you really rely on.
Cypher, you got anything you want to add or ask further? Yeah, you were fantastic. Thank you. Awesome. Thank you for that, Jason. Do you mind giving like an overview of the Atmos 14? It doesn't get a lot of airtime on office hours. You mind telling the folks a little bit about it?
Sure. Yeah. I'm going to actually just look up the specs manual specifically for the Atmos 14, because I did say plus or minus 2 earlier here on the show, and I think it's actually quite a bit better than that. Can't remember the numbers right off the top of my head, so let me just look up those numbers. I guess I need to log into the internet first. Just a minute, everybody. So yeah, Atmos 14. Probably one of the questions that we get a lot as well is that, do I need additional repeaters? So the Atmos 14 that Aroya sells is actually, it's a little beehive, and then it's got a sensor in the beehive. That beehive is a radiation shield. And this is all actually connected to your standard Aroya repeater. So anytime that we need better signal in a room, we need to go a little bit longer range. Atmos 14s work for that as well. And so it's just a repeater with the sensor connected to it. And so that's the high overview of what our Atmos 14s are. We do manufacture them to be supplied over typically PoE injection. Right now, we're working through some things to make it active PoE enabled as well. So right now, it's just a passive 48-volt DC supply. Reason we're doing that is because it's easy to run low voltage Cat5 cable throughout your facility so that you can install this in the best place possible. Cat5 is relatively inexpensive. It's lightweight. You probably already have it running all over your facility for your camera systems, security camera systems. And then the best part as well is you don't need a certified or licensed electrician to install that type of stuff. So in almost all of these cases, we're avoiding running extension cables. pretty much every facility I've ever been in, it's like running out of outlets already before they put the Aroya system in. So definitely nice to have that kind of infrastructure, easy installation design to it. And what the radiation shield is doing is anytime that we're in a lighted environment, some of those far red light waves that we were talking about are increasing the surface temperature of anything that it's hitting. So just like leaves, comes right back around to the leaf surface temperature versus air temp. Well, we're trying to represent air temp with the Atmos 14. So if the body of that sensor is getting warmer than the air temp simply because of the radiation that's hitting it and warming up the solid body of the sensor, then you're going to have an inaccurate reading. So that's kind of the whole point of a radiation shield. Pretty common in almost any environmental monitoring systems is having a good radiation shield. So a little bit of airflow through that thing, just a natural airflow is going to help keep the body of that at the same temperature as the air. So yeah, let's jump in. And do you want me to share the specs on this, or I'll just read through them here?
Yeah, drop them out. I also have them up. I have the specs here. We're looking at the temperature specs. Is that what you wanted?
Yeah, I was just going to go over some of the relative humidity and temperature specs. So,
Yeah.
all right, relative humidity for the Atmos 14 Gen 2s, we're looking at a resolution of 0.1% relative humidity. So resolution is just talking about how many decimals out are we taking a reading. So if we could be at 55.5% humidity or 55.6, that's the resolution. On some of the cheaper humidistats, you're looking at either 55 or 56%. So nice to have kind of an understanding of where are we at in between those intervals. Its accuracy, it is actually based on humidity and temperature, but in the operating ranges of cannabis cultivation facilities, it's on a plus or minus 1.5% humidity. So, same thing. If the room's at 55% humidity, that means that our sensor could read up to 76.5 or as low as 55. Whew, I got kind of wild there. Let's just go to 50% humidity would be the actual room humidity, and the sensor could read 51.5% and still be within accuracy specs, or as low as 58.1%. So always keep that in mind. And typically a lot of the sensors that I see, so one of the most common sensors I see out there is actually on a plus or minus 7% relative humidity, which is kind of just way too far off to be even making much value from those readings. So nice that thing's super tight as far as those accuracies. And for, let's see, for vapor pressure deficit, obviously that's going to be based on the humidity and the temperature accuracies, but it looks like they already did the math for us. So in the operating ranges of cannabis, we're looking at 0.15 to 0.2 accuracy in that VPD. So same thing there. Resolution in this case, we're looking at 0.01 kPa. I do believe in Aroya we actually round that to 0.1 kPa. So keep that in mind, that sometimes when you see your charts that look like stair steps, that's basically just rounding off the numbers coming in from the sensor.
Fantastic. Thank you for that, Jason. And actually, this is a perfectly timed question that we got from Kenny Keefe over on YouTube. They wrote in, is one climate station in a 20 by 30 room enough, or should I do two?
Yeah, so 20 by 30 room, we're looking at 1,200 square foot. Kind of our run-of-the-mill suggestion is one Atmos 14 per every 1,000 square foot. Obviously, if I have 1,000 square foot room that's like weird dimensions, then we're going to want two of them in there. But so you said 20 by 30, excuse me. So that's 600 square foot. And so one Atmos 14 should be pretty adequate as long as you're making sure you get that in the canopy height. A lot of times it's nice to raise it up a few times as those plants are getting bigger, just to make sure that it is, at the top of the canopy. You're not getting blocked airflow by being in the meat of the leaves, and yet you're not, 2 or 3 feet up above the canopy getting readings that aren't representing the canopy. Keisha, did you say you found the temperature accuracies on there? Because I didn't get to that.
I had it. Hold on. And pull it back up. Ooh, where'd you go? All right. So we have here for temperature accuracies plus or minus 0.2% degree, 2 degrees Celsius. Is that what you're looking for? Resolution 0.1 degrees Celsius.
So I'm going to convert that for those of us Americans here. So that's going to be about 0.35 degrees Fahrenheit.
All right. Bilbo dropped a couple questions in the chat. Bilbo, you want to unmute yourself? Or you want me to ask it? I'm just going to start reading.
Okay.
Oh, yeah, do it.
You want both of them?
Yeah, start with your first one.
When calibrating an irrigation skid, I've experienced different readings when I calibrate each ingredient injection individually versus the entire line as a group. The deviation is approximately 100 to 150 ppm. And do you have any insights or have experienced anything similarly? The probes that are reading that ppm/EC have been recently calibrated.
Yeah. That is to be expected up to a certain degree. Obviously, as those ingredients are interacting, they're going to be changing the electrical conductivity of the signal that most of those sensors are using to read that. And so typically, when we're in an A ingredient and a B ingredient, a lot of times they won't add up. So if we're at, say, 0.5 EC of our base and maybe 2 EC of our B component, a lot of times we'll see that a little bit higher or lower. The one thing to kind of make sure there, obviously, and it's pretty easy, is just making sure that the nutrients are mixing into solution good enough that we're not seeing some fallout. So we definitely don't want to have a precipitate, and that's usually that is why our ingredients always come in 2 parts. And that's why we need to make sure we're having good mixing chambers in between any of our dosing systems to make sure that all of those nutrients are fully suspended in solution.
Cool. And does the Aroya system have a provision now or in the future to incorporate an infrared sensor to monitor or track leaf surface temperature?
Right now, we do not have a leaf surface temperature that you can get with the Aroya system. I have played with them quite a bit in the past. Kind of just comes down to some logistical challenges is one of the reasons that we haven't put the energy to pursue that as a commercially available option from Aroya.
Thanks.
Those are great questions, Bilbo. Always good to see you. Thank you so much for that. All right, we got another question from Iron Armor also asking about some future plans from Aroya. So they wrote in, does Aroya have any plans on introducing a product that would be able to integrate your HVAC and dehumidifier system to be controlled by the Atmos 14?
Question we've gotten tons in the past, and for me, probably the biggest challenge is that right now our Atmos 14 limited readings are limited to 3 minutes. So every reading comes in 3 minutes, and that's just not enough to make good HVAC changes. The best HVAC systems are using PID loops to make sure that they're continuously trying not to overshoot their set points, and so right now, probably not in the near future. We might have the opportunity to turn up some of those data reporting speeds. We're not currently working on that right now. However, we do have an API. So I've worked with a number of clients that have set up some types of integrations, taking the data right out of Aroya. So API basically just asks our server for the data. Our server replies the most recent 500 data points for every sensor in a facility, and then they can start doing information with that. what I do like to do with our Atmos 14 as far as HVAC stuff is making some programming that validates what your HVAC sensors are saying. So even though I'm only getting a reading every 3 minutes, not enough to make a decision, it's enough to throw a red flag if it is significantly different than the reading from your HVAC system. So obviously, being that the Atmos 14 is pretty damn reliable and extremely accurate, as we just went over, it's nice to use that as a checkpoint to say, all right, maybe I do need to invest in a better HVAC sensor, or now is the time to pull my wall-mounted HVAC controller and make sure that the sensor is in my canopy. So as far as other types of integrations, got some people using the API for pulling water content and EC information and doing it as they please with it. So that's one of the beauties of the open API, and why we don't support necessarily the ways and the technical background on how you could build that programming. Any of these larger facilities, some of the MSOs that we work with, they have dedicated system engineers, IT teams that are capable of understanding how it's a very basic, it's a standard REST API system. So
Fantastic. Thank you for that, Jason. Yeah, like Aroya's got a lot of functionality. There's a lot that's possible with the way we have our system set up. So we always appreciate these kinds of questions coming from folks. So thank you for that. Bilbo wrote in the chat here, that's a whole separate business. Yep. We're always watching it. So awesome. All right, I'm going to keep it moving here. I got a question here from Cuban SE. They wrote in, heard it's best to increase pH at the end of flower in cocoa, say 6.0 to 6.2. I have always just run 5.8, 5.9 pH clone to harvest. Is there a pH chart you'd recommend to see the value in increasing? The reason I ask is all the pH charts online are different. So how to be sure which one is the most accurate? Thanks, guys. What advice do you have for Cuban SE?
Yeah. So yeah, I actually don't mind if the pH rises up a little bit, kind of specifically exactly in the ranges that you were talking about. And let's see, nutrient availability by pH. I was actually just looking at these on Tuesday. I did some instructing down there in Humboldt County, and I was bringing this up to talk a little bit about how it changes nutrient availability to the plant when we're at different pHs. And one of the reasons that it might be, those charts that you're seeing are so much different is it's very dependent on the substrate that we're in. So definitely don't use the soil pH chart if you're in cocoa, and don't use the rock wool pH chart if you're in cocoa, for examples. And I don't know necessarily if I have a direct preferred link for the cocoa one. pH chart for cocoa. I'm just going to Google it and see if we find one that we like. And actually, I might jump on here and share with the audience so that they get an idea of why we're talking about this.
We do love an overview, Jason.
See if we can build a gnarly feedback loop when I join the call. All right. Let's share. So this was my search term, nutrient availability pH chart, cocoa, and some of them don't do a great job of labeling specifically what they are for. One of the easy ways is also to kind of just look at where those nutrients are at as far as the pH goes. I'm just going to pull up a few, and if I don't find one for cocoa, we're just going to talk a little bit about how it affects plants.
A lot of options out there.
There is. Some of them are nicely colored, and some of them are a little bit different shapes than others. That one's soil.
So if you encounter discrepancies between a couple of different pH charts, like what's a good rule of thumb for that? Pick a number in the middle.
Use the more reputable one.
Okay. There it is.
That's what I would do. All right, I didn't just quickly find. Yes, so don't do what I'm doing, where I'm just pulling up one of the first easy ones to read that I can find. This one is for soil. Sorry, I couldn't find the cocoa one real quick just by browsing here in a few seconds. But why does this matter? Why does it work to let it rise a little bit towards the end of flower? Basically, so at specific pHs, the plant has better or worse solubility to macro and micronutrients. So up here in the top of this chart, we're seeing nitrogen, phosphorus, potassium, and then getting into some of the micro, sulfur, calcium, magnesium, etc. And as you can see, some of these nutrients are much more available to the plant in low pHs. And then some of them are more available to high pHs. And for the bulk of the growing cycle, we want to be able to have some availability from all of this. So we're going to be kind of just riding the line right there, where we can see that, all right, we've got just just starting to get on the edges of specific ones. So the low edge of maybe phosphorus and calcium, for example, we're pretty close to middle range. Iron, we're actually at the high end. So if we are getting towards the end of flower, then when we let that pH rise a little bit, we're just going to change how the availability changes to the plant as well. So there's going to be a little bit better balance of nutrients available if we go up, say, 0.2 points. As far as in application, you're not going to see huge changes in the plant's response to this type of activity. But if you're doing it and you have had success, do it. Keep doing it.
And yeah, if anybody out there does find a really good, reliable pH chart specifically for cocoa, feel free to let us know. Give us your recommendations. We do appreciate the feedback. All right. Well, folks, we are going to actually hop off a little bit early today, but wanted to make the announcement. Y'all are in California. Next week is the big show, Holoflowers Santa Rosa. You're for sure going to see me and Jason walking around, right? So yeah, if you're going to be there too, let us know, hit us up so we can come by, say hi. If you see us, come over and say hi. But Jason, before we hop off a little bit early today, anything else you want to say?
Have a great day.
That's it. Yeah. Happy spring, y'all. Stay warm. All right. Thank you, Jason, for another great session. Thank you to everybody who submitted questions today. We appreciate you. And of course, thank you, producer Chris, for the magic behind the scenes. All right. We do this every Thursday, and the best way to get answers from the experts is to join us live. To learn more about Aroya, feel free to visit our website, click a link to get a demo, and one of our experts will tell you all the ways that Aroya can be used to improve your cultivation production process. But as always, let us know if there's a topic you'd like covered in a future session of Office Hours. You can post questions anytime via the Aroya app. Feel free to drop them in a chat. Send us an email to support.aroya@metergroup.com. Send us a DM. We are on all the socials. We definitely want to hear from you. And we record every session, so we'll email everyone in attendance a link to the video from today's conversation. It'll also be on the Aroya YouTube channel. Like, subscribe, and share while you're there. And if you find these conversations helpful, please do spread the word. Thanks, everybody. We'll see you next time. Bye.